In this video, I want to give you guys a little refresher about Taylor series. And the whole idea of Taylor series is that if you have a function f, you can come up with an infinite dimensional polynomial that basically approximates f of x as close as you like. Take larger degrees and the polynomial gets closer and closer, at least within some sort of radius of convergence. But just as a reminder, we have these coefficients here, and the coefficients are the nth derivative evaluated at 0 if we're centering our polynomial, or centering our function at 0. We're going to take the derivative at 0. So it's the nth derivative at 0 over n factorial, so that's your coefficient. Usually, we call this bit here an, that's a coefficient, and then times x to the n. And the whole idea that we're going to use is if we know the function here, then we'll be able to find these coefficients by taking the derivative. In fact, we're going to do some more clever things, because sometimes taking nth derivatives is quite laborious, so we might be able to do a few tricks, but this is a method we can always get to our coefficient an with by taking the derivative of the function. So that's really, really good. And we really like these power series. So power series are very, very nice versions of Taylor series, or Maclaurin series, if you want to call them that, since they're centered at 0, where basically you have a fixed coefficient here. So this is the same thing, if you like, as a plus a x to the 1 plus a x squared plus a x cubed all the way to infinity. And if you remember from your second calculus class when you're talking about sequences and series, that there is a nice formula for power series. It's a over 1 minus x. And this is something that we're going to use a whole bunch going forward. So try and remember this guy here. And if you forget why this is true, it might be a good idea to go look this up in your calculus notes, or you could probably find a quick YouTube video that explains this in about a minute. But we are going to abuse this fact over and over and over again. So if we do have this infinite polynomial where the coefficients are just 1 in front here, this is just 1 over 1 minus x. And again, we have to worry about things like radius of convergence if we care about things in calculus. But for our purposes, we don't really care about that. This is just a power series with some formal variable, so it doesn't really stand for anything. So we're thinking about this as a formal variable. So we're not really using that to plug in numbers or to stand for numbers. It's just a symbol. So these guys here, they're all formal variables. They don't really stand for anything. They're just a symbol. Now what I could do, since I have all my calculus techniques, is I could take the derivative of this function, and since this power series equals this function, then the derivative of this function should equal the derivative of the power series, and that will give us a new power series. So that's a very important technique. So let's look at that on the next slide. So here we're taking the derivative of 1 over 1 minus x, and you guys can check quite quickly that that's 1 over 1 minus x all squared. And if I take the derivative of each term in my power series here, so 1 plus x squared plus x cubed, etc., well, I just use the power rule here, and I get 1 plus 2x plus 3x squared plus 4x cubed, and in some sense all of the terms look like n plus 1 times x to the n. So what I can say here is I have this new power series, or it's not quite a power series, but this new series where I know what it equals. So if I have n plus 1 times x to the n, because remember that's the generic term in this infinite polynomial here, well, that's just 1 over 1 minus x all squared. And that's another important one to remember. That will come up during this class quite a bit. And so this is just a quick video reminding you of the ideas of Taylor series and some power series techniques. We could also, if you like, we could take the integral of sequences to obtain new sequences, etc. So we can use all of those calculus techniques. In the next lecture, we're going to talk about something called generating functions, which uses this idea to be able to study sequences very easily. And these sequences are usually things that we're counting.